Yeah, good day everyone. You are welcome to my YouTube channel. My name is Engineer Shear Isa Adebisi, and I'm going to be your instructor on this particular design. I know it's been a while, so yeah, but I'm back now. I'll be dropping videos for you back to back. Yes, I'll be dropping videos on steel and reinforced concrete and on foundation design, and I would also be I've also I'll also be creating some videos on Udemy, some courses on Udemy. I'll be creating videos on high-rise buildings. I'll be creating videos on low-rise building. I will also be creating videos on design of a retaining wall. I'll be showing you how to design a counterfort retaining wall, and I'll also be showing you how to design a cantilever retaining wall. But it's actually a course that is actually going to be on Udemy. Without wasting much of the time, let's get to this. So we are going to design this. We are going to design this. So this is a 20-meter beam span. It's a 20 meters beam span. So I want to show you the principles and the concept on how to design a beam 20-meter span. It's actually a long span beam. Now, without wasting much of your time, let's get straight to the design. So you come here, you go to new project, you go to new project. So I want to show you how it was being modeled. So let's call it 20 meter long span beam. Yeah. Then let's pick the code. Maybe BS code. Okay. Let's do BS code. Let's do BS code. Done. Okay. So let's model a 20-meter long span beam. So let's have this. Let's have this. Okay. Then let's have this. So let's offset 20 meters. So we have this. Okay. So let's draw this. Right. Then let's put a column. Let's put a column here. Let's have this here. Let's have this here. So because the span is actually 20 meters. So let's do a sizing of L over 10 just to see. But I will show you the major criteria in what we're going to use in the final sizing of of a of a beam. I'll show you what you need to consider when you want to size a beam. The most important factor, the most important criteria that you consider in it. Now let's let's do okay, let's do this. So let's do this. So let's do L divided by 10, which is equals to what? L is what? L is 20 meters divided by 10. That will cancel 0. 20 meters divided by 10 meters. So we'll be having a 10 meter. So we'll be having a 10-meter deep beam, right? We'll be having a 10 10-meter deep beam. So let's model the beam. 1 meter deep beam. I meant 1 meter deep beam. So let's model the beam. Okay. So let's do let's do 400 by 1 meter, the trial size, right? And let's update. Okay. So we have that. So we need to make this. Let's make this 400 by 400 properties. Let's do 400, and let's see. So it is advisable you make your it's advisable you make your column width the same size, the same width of your beam. So since the beam is 400 by 400, so we have this. Yeah, the beam is 400 by 1 meter. So that was why I made the column to be 400 by 400. So this is what we have. Now let's load this. Let's load this. Let's go to edit. Let's go to edit load. Let's okay. So let's put a wall load on it, or a UDL as the case may be. So let's have this. Okay. So let's have this also. So let's have a wall load. So let's okay. So let's design this beam. Yeah, let's design this beam. Yeah, let's design this beam. Let's have this. Let's have this. Simply supported. Simply supported. And it's having a load of say, let's say it's having a load of 40 kilonewton per meter. A UDL of 40 kilonewton per meter. So let's design this, right? Okay. So let's do so now. This is where you need. So this is where you have to be this creative now. So the one unit weight, you can make this. You can make this 3.47, right? Now remember that the goal is actually what? The goal is 3.4, right? The goal is actually only 40 kilonewton per meter. So let's let's bring out our calculator. Let's bring out our calculator. So let's have 40 divided by 3.47. So we have 11.5, right? So we have 11.5. That's what we have. So that's like 11.527, right? So this should be 11.527. See, so we have this approximately 40, right? Right. So let's click on this and let's do okay, right? So this is what we have, right? So we need to now, because we already inputted the actual UDL. So let's go back here. Let's go back here. So let's go to loading. Let's go to load cases and combination. So let's delete everything here. Let's delete and let's go to load generator. So let's change this to just to 1.0. 1.0. So it doesn't create factor. So let's make this right. Okay, so that's what we have. So 1.0, 1.0. So let's click on okay, right? Now, so let's now run the analysis now. But before that, let's go to settings. Let's go to settings. Let's wait for it to come up. Let's wait for it to come up. Okay, so the beam. I'm actually interested in the beam. Okay, let's do for the okay. Let's set parameters for the column too, right? So let's do longitudinal. So let's go 16, 25, right? Let's the length should be 10 mm, right? Okay, so let's do spacing of 200, right? Let's go to the beam itself. Let's go to the beam proper. So the beam, let's do 16, 25, right? Let's do 10. Let's do 10, right? So it said concrete cover will be calculated according to the code provision if 0 is entered in this field. So let's leave it at 0. Let's leave it at 0. So let's make this 200. Let's make this 200, right? So let's also make this 200. Okay. So I think our settings has been made. Our settings has been done. Now the next thing is to come to, let's go to analysis. Let's go to building analysis, right? Let's go to building analysis. Yeah, let's wait for it to come up. So let's go to edit material, right? So you see that we are concrete grade is our concrete grade is C25, which is okay, and our steel is 410. So let's run the analysis so I can be able to actually explain the principles of the design. The principles will be explained to you in total when the analysis output actually comes out. So let's go to analysis, building analysis. Yes, right. Now let's check this, let's check this, let's check this, let's check this. Now let's click on building analysis and let's wait for it to come up. So like I said, be creating some courses, some course video on steel portal frame, I'll also be creating courses on reinforced concrete structures too. But it's gonna be on Udemy. I will also create some videos on YouTube. But if you want to get the full core in which it's been broken down, you would actually get it on Udemy. But you still have videos that are educational videos on structural design, on RC and steel structures. You have it. Then I'll also teach you guys how to design a retaining wall. But the software that we're going to be using is actually Start Pro. We'll be using Start Pro for the design of the retaining wall and not Prota structure. Now remember in my videos, I said it categorically that we're going to be designing with two softwares, Steel, Start Pro and Prota structure. Now the analysis result has been completed. So let's bring out this. Let's go to review. Uh, yeah, let's see. So you can see that the beam is failing. The beam is failing and the column is also failing. So let's now try and interrogate why the beam is failing. Now this is where I want you to pay close attention now. Now, so now I'm gonna bring out a spreadsheet now. I'll use the spreadsheet to actually explain the principles of design of long span. The principles of design of long span. I'll use the spreadsheet and explain it to you. Now I need you to pay close attention. Yeah, I need you to pay very close attention. Yeah, okay. So we'll be making reference to this spreadsheet now. Now the first thing we need to look at now is for us to look at the analysis output. So you click on this, then you click on section design, then you click on OK, right? Now let's wait for it to come up. Let's wait for it to come up. Still loading. Still loading. Okay. So you can see that it's actually failing. Okay, it's passing in shear, but it's actually failing in deflection. Now, 20-meter span is a lot. So you would actually expect it to fail. And what is even telling me here that it's actually requiring a whole lot to pass. Now, let's go to the diagram now. Let's go to the diagram. Let's check the bending moment and let's also check the shear force. But we don't have issues with the shear, but is failing in deflection. Wow. Can you see? Can you see what we have? What we have is 2000 and 2088 bending moment. That is what we have. So what this is actually telling us is that it's actually going to require a whole lot for it to pass in terms of the section sizing. Now, this is what we have. We have 2088.7, right? Okay. So let's now do something now, right? Let's do something. Okay. So we have this, right? Okay. So let's make this 600. Let's make this 600, right? And let's make this 1500, right? The rebars. Okay. And let's click on okay. Now you see that it has passed, right? It has passed. Let's go to section design. Let's go to section design. So it's actually close. So the span, the span over depth ratio is actually less than the section size. Now you see this now. Now let's try something. Let's make this 1400. Let's see. Let's make it 1400 and let's see what we have. Let's go to section design, right? So you see that it's actually very, very close to 60.2. So we have our section now. So the section is what? 600. We have 600 by 1400. Now the column is failing now. The column is failing. Now remember that the beam is having a width of 600. The column is failing. So let's see. Let's try and make the column pass. Now let's wait for it to come up. Okay. So this is what we have. So let's look at what we have in terms of the moment. So you can see that we actually have a moment of 747, right? Now, so let's make this 600 by 600. Update, reset bar, interactive design, right? So let's click on OK. Let's click on OK. See that the column has passed. Same here. So let's go to section, right? So let's do 600 by 600. Update, reset bar, interactive design, right? So let's click on OK. Let's click on OK. Now, this is actually you using the software to actually analyze it. Now, let me now teach you the principle in terms of how you actually approach this when you want to design a long span beam. Now, let's come here now. Let's come here. This is the spreadsheet. This is the spreadsheet. Now, let's now check this now. Now, remember that my moment is what? What's my moment? Okay, let's go back to the analysis result. Let's go back to the analysis result. My moment is what? My moment is 2088. That is what my moment is. Now, I need you to put that at the back of your mind. The moment is what? 2088. Now, this MU you're seeing is the moment capacity of the section. Now, let's put the moment here. 2088. Let me confirm again. 2088. Okay, that's what we have, right? That is what we have. Now, this MU you're seeing is the moment capacity of the section. That means that is the capacity of what the section can carry in terms of the moment. Now, let's now do this now. Now, I need you to pay close attention to this MU, the values of this MU. You can see we have 57.0 here. Now, I need you to pay close attention as I change the section. Now, this is where the section property is. Let's do 400 by 900. Now, you see that the moment capacity of the section has moved from 1101.7 from 57 to what? 1101.7. But what we are seeing here what you're seeing here, is that the moment capacity mu is less than the moment in which the beam is generating. Now, the moment capacity should be greater than the moment your beam is generating. But there are some textbooks that will tell you that the distance between that your moment capacity can be less than the moment your beam is generating, but the distance between the moment capacity of the section and the moment that is being generated from your analysis output shouldn't be much. Maybe like a difference of say 50 or 100. But when you're designing a long span beam, it is actually advisable that you ensure that the moment capacity of your section is actually greater than the moment that your beam is generating. Now you can see here that my mu is what? Is 1107. Why this one is what? 2 This one is 2088. So we still need to check. That means that what it's trying to tell us is that we need to go forward as regards the moment capacity of the section. Okay, right? Now we have 1101.7. So now remember that what the software gave us is what? Okay, let's check what the software gave us in terms of section sizes. In terms of section sizes. So the software gave us okay, let's close this. Now the software gave us what? Okay, so let's go to section design. Let's go to beam. And the software gave us a section of 600 by 1400. Now let's see now. Okay, let's do 600. Let's do 1400. Very good. Now you can see here now that the software is also operating with this principle now. At the end of the day, the moment capacity of the section that was needed for the 20-meter span beam to pass is actually way greater than the moment in which the beam is actually generating based on the load condition that's acting on the beam. Now, you see now that with this now, your 20-meter span beam is actually okay in terms of the moment. Now, let's look at the shear force. Then before we now look at the reinforcement detail that was actually provided, let's look at the section. Now, the shear force, sorry. Let's look at the shear force. So let's click on this. And let's look at let's click on this, right? Let's go to section design. Let's go to diagram. Now the shear force is what? 593. The shear force is 593 kilonewton. Now let's look at this. Now remember that what he provided was Y10 at 125 based on the shear force. Now we have what? We have 593, right? We have 593. That's what we have, right? 593. And so the shear force is what? 593. Yeah. So now let's look at what the software actually provided. The software provided the support is actually providing. Let's see if we can go forward. Okay, we can still go forward. Okay, we can still go forward. Very good. We can go forward. Right? We can still go forward. Very good. Now let's compare what the software provided. What we have here is actually 2 legs of Y10 at 200. Now let's see what the spreadsheet is also giving us. The spreadsheet is also giving us what? It's also giving us 2 legs of Y10 at 200. You can see the 202 here, Y10 at 200. So that is what we have. Let's look at the reinforcement. Let's go to the detailed drawing. So let's wait for it to come up. So let's wait for it to come up. Let's wait for it to come up. It's loading. It's loading. Let's wait for it to come up. Right. Okay. So let's wait for it to come up. Okay, it's still loading. Yeah, it's here. So we have two layers of HY25. We have a sidebar. We have a sidebar of we have sidebar we have sidebar of this should be okay. I'm not seeing it properly, but we have a sidebar. For a beam of 1.4 meters, you definitely need a sidebar. We definitely need, okay, this is what we have. So we have this section. We have spacing of this thing 250, spacing of 250, but you, but the sidebar will definitely be provided due to the depth of the beam, right? So this is the sidebar here. So let's close this. This is the sidebar. This is the 3y16 both side. Now this is where I'm actually going to stop the video. Now if you have any question as regards this video, you can drop it for me in the comment section. Like I said, I'll be dropping more videos for you on the YouTube channel. Thank you very much for watching.